Hey guys, today we will be talking about alkynes. I will get back to alkenes, which is a double bond, but alkynes are a little easier and they're good to know. They're also very interesting when used in chemical facilities. So today the game plan is we're going to start off with nomenclature. I'm going to briefly go over acid-base, and then we're going to talk about some carbon bonding. I'll have other videos of more complicated stuff down the road, but for right now we're going to talk about the introduction and basics to alkynes. So, what is an alkyne? An alkyne is a 3-bond base. So, as we see right here, we have a hydrogen and a hydrogen on the other side, and then here's 2 carbons. In between the carbons are 3 bonds. An alkene, so actually right up here, this is an alkyne. Below, I want to draw an alkene, which is a double bond, which is used a lot in chemistry. A lot of alkenes, especially on the ACS exam, which I recommend those that will be taking it purchase one of these booklets from the American Chemical Society. They are very helpful. Help me study for my exam. And then, so anyway, get back on tangent. Then we have alkanes, which is something you've known since chemistry in high school. This is a single bond right here. Just a little sigma bond. So, alkene, alkyne, alkene, alkane. So, let's talk about some more nomenclature and examples. So a big thing with alkynes is the names. I'm going to talk about just 2 basics. So right here we have the IUPAC name and we have a common name. This chemical right here, ethyne, ETHYNE deals with the triple bond. That is the IUPAC name. Why? Here's the ETH for 2. There's 2 carbons. YNE, triple bond. There is a triple bond right here. The numbering system does work out the same too. Like I said, IUPAC has its set rules. Now when we get to a common name, we have acetylene. Confusing. Think about it. It ends with an ENE. An ENE, that's usually a double bond. But in this case, it's used for a triple bond. You know, chemical plants and everything like that, you know, they come up with these names. Chemists come up with these names before IUPAC was around. And it gets confusing. Because now you think, oh, is that a double bond? But no, it's a triple bond. So in this instance, you probably want to stick to the IUPAC because it's a little bit easier. But, like, it can get very complicated too. So we will use common names as well. So either way, it's a trade-off. So let's do some examples. Alright. So, let's start off with something basic. Let's get some markers going. So we'll have a CH3, do CH2, CH2. So I'm just drawing this out, no line angle. This is simple for you guys, so you guys can understand it better, of course. So what is this molecule? Right here. Look at it for a couple minutes and think. Give me the IUPAC and the common name. Any ideas yet? Alright, well, I'll do this with you. So what do we have here? We have how many carbons? 1, 2, 3, 4, 5. 5 carbons. So what does the IUPAC say? Well, we know it's pen. Pent. For 5. Like a pentagon. So now, oh wait, there's a triple bond. So now we have to go by an alkyne. So now it's pentyne. So where is this located? Which carbon? We're not going from highest, the highest number. We're going to the lowest number, 1, 2, rather than 1, 2, 3. So the correct name is 2-pentyne. Now the common name is easy. Since there's no rules or regs, we can just come up with it. So let me write this down. IUPAC, common. So the common name, what do we got going on here? We have a methyl group and we have an ethyl group. So we can write it as ethyl, methyl, methyl. Oh yes, already going back to the common name. And we're going to use this term right here. Acetylene. Ethyl methyl acetylene. So that's that. Just remember, on ACS they don't use common names, just as a reminder. So let's do one more example. You guys can choose what you want. I'm going to pick the common name in this, but you can do the IUPAC name. So we're going to have a ring. So what is the name of this? Well, let's not bother with an IUPAC name. If your professor says give you a name, we'll just do the common name. So what do we have here? We have a triple bond, and we have a methyl, so we have a single. So we have a methyl. So we have, also, so besides the methyl, this right here, cyclohexyl. Cyclohexyl. Mind you, it's not at the end because this is what we're prioritizing right here, is that triple bond. And then we're going to stick to the common name, so it's acetylene. So here we go. Cyclohexyl, methyl, acetylene. So that's that. Now, let's discuss some fundamental rules for acid and bases. I already drew this out. Figured it'd be a little easier so I can just jump through it. Least acidic, mid acidic, most acidic. Here we have one bond. Here is an alkene. Here's the alkyne, the most acidic. Why? Because it's such a strong bond. It's just like tug of war. It's also like what you learned with acid and bases earlier in organic chemistry and in general chemistry. You know, hydrogen, OHs, and so on and so forth. So, we're going to do an example which does involve this. But, we're going to jump to carbon bonding. So, carbon bonding. What are we going to start off with? So say we want to get this molecule. With that negative charge. Well, we understand we just can't happen to have that in the store or in the lab. We have to make it. So how do we make this? How do we make this basic? Well, let's get some markers. So we're obviously on the same molecule, but with a hydrogen on it. So we're going to have our CH3, CC, with a hydrogen. This is what we're looking at here when we're trying to get to this. So what are we going to do? Well, we have to use something to react with it. So what's something that's very good? Any guesses? Well, one of the strongest is the sodium metal. Na with like a little 0. It's like a degree symbol. What does that do? That rips off that hydrogen because this sodium metal is so strong. It will tear off that hydrogen from the rest of this molecule. So that's going to turn into this. we can say goodbye to the H+, because he's long gone. So then, now that he's gone, now we have a negative charge. Oh no, so now what are we going to do? Now, since we finally have this, now we can do a SN2 reaction with carbon bonding. Our plan is, we're going to get HBr, we're going to throw that in there, and we're going to build another hydrocarbon onto this molecule. So let's throw this on in here. So we're going to have our HBr. Actually, I'm going to put them over here. Alright, I want to rewrite this. So everybody hopefully has the first part here. If not, just rewind the video. So now we need to get a hydrocarbon on here. So what are we going to do? And I apologize, it's not HBr, it's CH3. There we go. Now that's a little better because we want this hydrocarbon, not a hydrogen, because we just took the hydrogen off. And plus we have bromine, we can get it mixed up with SN1 and elimination, and that's a whole different story. So, anyways, so what we're going to do, we're going to break this bond. So this bond needs to be broken. So, let's break this bond. Have our electrons leave, well, move. Well, I don't need to draw that because we're not doing alkyl halides. So when we break this bond, now we're going to have CH3 plus, and then we're going to have a Br negative. So we have this floating around, right? Well, the bromine isn't going to want to go to another negative because they don't attract. Well, opposites do attract, but in this case, we want this positive here. So this guy, looking for somewhere to go, he's going to be floating around. And what's going to happen is a bond's going to form between these two. So we're going to have our CH3. And the bond is so strong because, like I mentioned before, it's a triple bond. It's not a single, it's triple. It's like having 3 pull against one person. And who's going to win? The 3 people. So now we have that. So now this guy is like, okay, we need to do something here. So we have this negative charge. But look, now we have a positive over here. Mr. Bromine's by himself over there. Doesn't matter anymore. We're focused on this reaction right here. So then we have our CH3, and they're going to come together. So I want to draw this out a little better. For hydrogen, hydrogen, hydrogen. And then we got this plus charge. And then we have the negative. They're going to come together and form a bond. I know this is very dramatic, but this is what happens, and this is big stuff right here. So now we're going to make this new molecule where we got, I'm going to draw out the whole thing, entire Lewis structure here. Actually, I'm going to color in that bond so we know where they took place. Right here. That very important bond. I'll tack on our hydrogens. And ta-da! That has just been made. So, now what do we have going on? We have a new molecule that was just formed. Okay? And that right there is basic carbon bonding for alkynes. For extra credit, or if you want to take the time, name this molecule and check it out for yourself. Thank you.